starting off with the pH, which we find by using a negative logarithm. Whatever your H plus concentration is, we take the negative log. Again, the only reason why it's negative, it's not that we have a negative number, but negative log tells us that we're that many places behind the decimal. So that's really what the negative log is doing for us there. So as a quick example, what is the pH of a 0.050 molar hydrochloric acid solution? So again, honestly, guys, the toughest part of a lot of this might be identifying when you have an acid, when you have a base. Well, that H out in front tells us we have an acid, so that is our H plus concentration right there. We can solve for this using that formula we just showed. We already have the value we need. That's this right here. So we can just plug that right in. And calculate our pH. Hey, get out your calculators. Get out your calculators. Work through this with me. Or plug them in. Make sure you guys are doing them right. Again, nothing worse than knowing how to do it, but not doing it correctly because calculator's not, you're not using calculator properly. So give you a minute here. Grab those calculators. Let's punch this in together. Let's make sure we're all getting the same answer. Again, if you think about it, when you're doing your homework, you can't double check you got the right answer. You just got to trust what the calculator tells you. But right here, right now, you can plug it in with me. You can double check. You can make sure you're getting the correct answer. Most of you have a calculator like this. First thing you want to hit is the negative button down here at the bottom. And then we come back up here, close to the top, we hit the log button. And we just enter a number. 0.050, parentheses up, and there we go. Now keep in mind, for a pH and for pOH2, when we get there today, the number in front of the decimal does not count as a significant digit. It's just telling you how far behind the decimal you are. So we're looking for two significant digits, the 5 and the 0 to the right. So two significant digits would be the 3, 0. And that 1 out in front, it doesn't count. All it does is tell you how far behind the decimal you are. So 1.30. That's our pH. Not too bad, huh? How about to go the other way? What if you have the pH and need the H plus, excuse me. Well, the 10 to the negative pH, whatever that is. 10 to the power of negative pH, which is your pH, H plus, wow. As an example, so we have a solution. We know that the pH, we can take that probe and we can stick it in our solution and we can find our pH to be 7.7. What is its hydrogen ion concentration? Well, notice I wasn't able to tell you that it was like an HCl solution this time. I couldn't have told you that. HCl is an acid. We know for a fact this is not an acid, 7.7. So kind of remembering the gist of pH. Below 7 is acid. Exactly 7 is neutral, and above 7 is basic. Well, it's not much above 7, but it is above 7. This is a basic solution. We're working with a base here. So it definitely can't be some kind of acid. This wouldn't work. All right, so we're going to use the formula we just took a look at. We have our pH at 7.7. So 10 to the power of negative 7.7 will give us our H plus concentration. I like to use the caret sign. Again, great chance you guys enter it in calculator just to make sure you're doing it the right way, coming up with the right values. You can do that now with me here. See that you get the right values. So I go 10, and then I use the caret button. There's a couple other ways you could do it. 10 caret, then I've got negative 7.7. Oops. Hit enter. Hey, double check though, real quick. Did my calculator round? The way that I double check is I hit second, DRG right next to it. Go over to psi. Oh, yes, my calculator definitely rounded. Now for this particular problem, it's actually not a huge deal because we only want one significant digit, that 0.7. But if this were a different type of problem, that extra rounding that the calculator did might be a pretty big deal. So watch out for that. Make sure you're watching the exponent, but watch out for that. Your calculator will do some rounding, and it can cost you some points. Again, for this one, it's not going to because we're just working with one significant digit because of the 0.7. That's the only significant digit. So 2 times 10 to the negative 8 molar. So we do need a unit on this. pHs don't have a unit, but concentrations do. Questions so far? Just coming back to you guys, ringing a bell. Good deal. One more formula we talked about then before you guys took off. Your hydrogen ion concentration times your hydroxide ion concentration is always equal to 1.0 times 10 to the negative 14th. And that's molar squared. It's kind of a made up unit. We just need it so that the units work out in the math. And again, a quick example of how this works. And this allows us, as long as we have one, we can always find the other. What is the hydroxide ion? Hydroxide ions OH negative of the example above. So here's our example above. And I've got my H plus ion. I already solved for that. Now they're asking for the other half, the OH negative. Hey, good. Again, good habit. To rewrite your formula. And then isolate the variable we're looking for instead of just plugging in numbers. I know it's a habit of you guys just to start plugging in numbers as soon as you see them. That can get confusing. You forget how you want to go, where you want to go. So before you plug in any numbers, let's rearrange it so I can get what I'm looking for, which is the hydroxide ion. I get that where I want it. I need this on a side by itself. So to do that, I divide both sides by H plus. All right, there we go. We've got hydroxide ion on a side by itself. Now we're ready to plug in the numbers we have. This is where I want to be careful. This number up here is rounded. Whenever I can help it, I want to use extra digits. I'm going to go back to my calculator. back to that number I had before. I'm going to use at least 2 extra digits, but I'm going to round or underline them, excuse me. So my H plus concentration, 1.99, and then the number after the 9 is a 5, so it's enough to round up. So this becomes 10, 10. Oh man, today it's not going to change anything at all. Yikes. Hey, that happens. That's okay. But here is my actual hydrogen ion concentration. Again, for this particular example, it's not going to do anything. Look, I'm working with 2, and I'm working with 2, but there are times where it will. So I want to carry a couple of extra digits, but I underline them to show that they are not significant. And then there's my unit, molar. For this one, I'm going to use that big E button because that is the times 10 to the 14th. So 1.0 big E, negative 14, divided by 2.00 second big E, negative 8. And there we go. I can write just the 5. I don't need to put 0, 0 or anything because we are just going to have one significant figure in the answer because of the 2. And there we go. Our hydroxide ion concentration is 5 times 10 to the negative 7 molar. Questions? You guys remember doing this before break? Kind of rings a bell. You actually had a homework. It's not due till tomorrow night. I think some of you at least got started on it. If you hadn't yet, make sure you guys are working on that tonight for sure. Questions over this first little bit? Everybody's good so far? All right. Well, let's take a look at the new stuff then. Guys, if that stuff we just looked at, you're like, yeah, this is pretty simple, pretty easy, and hopefully it is. This new stuff is nothing. No big deal at all. The pOH, as you probably guessed by now, so remember H and OH, those are the 2 halves of water. H and OH. We're all pretty familiar with the pH scale. That's strength of an acid. It's telling us how much H pluses are there. Well, the pOH is the exact same thing, except for bases. So it tells us how much OH negative is there, how much of the other half, the hydroxide ion is there. Like I said, though, it's opposite. You got to kind of be careful here. Numbers below 7 are basic. Like I said, opposite. Seven is still neutral. That hasn't changed. 7 is still neutral, and then numbers greater than 7 are acids. So like I said, it's opposite of the pH scale. Again, kind of paying attention, making sure you guys are comfortable with what you're working with, whether it's H plus hydrogen ion or hydroxide ion, it's an acid, whether it's a base. What you have is going to be key. The rest of it's pretty easy. This should look really familiar to you guys. Doesn't that look familiar? Not a whole lot new. Like I said, the toughest part is probably just going to be figuring out what your acid, what your base is. Just like we did on the other side, quick example here. What is the pOH of a KOH solution? Again, we see that OH. We should think base. If the concentration of that solution is 0.025, again, that means that the concentration of the OH negative is 0.025. It's going to go into water. It's going to dissolve. You have the same number of OH negatives. They have KOH. So that's where that number comes from. How we're going to solve this? Well, there's our formula. We already have our OH negative. That's this right here. We just plug this all in. And crunch. Negative first, it's down here at the bottom. Log up here near the top, 0.025. Close parentheses up, and there we go. Again, two significant digits. The number in front of the decimal, just like with the pH, doesn't count. All that's doing is it's telling us how far behind the decimal we are. A little bit behind the decimal. See, makes pretty good sense, huh? Going the other way. If you're looking for the hydroxide ion concentration and you have the pOH, just like you did with the pH, just 10 up to the power of the negative pOH, whatever that is. So our example here, what is the OH negative, the hydroxide ion concentration of a solution with a pOH of 3.623? This time they're giving us the pOH. They want us to go backwards. Well, use this formula right here. We have our pOH. That's this value here. So we can plug that in. (10 to the power of negative 3.623 will give us our OH negative. And answer that 10 up to the negative 3.623. That's three significant figures. Again, we only count them after the decimal for pH or pOH. So three significant digits would be 2.38. The 2 after the 8 is not enough to round up, so we'll keep it there. And then don't forget about the exponent. 2.38 times 10 to the negative 4th. And you do have to have a concentration, a unit, on a concentration. So our hydroxide ion concentration does need to be lowered. We didn't need one up here, pH and pOH. They don't have units, but our concentrations, they do. Questions? All right, I've got one more formula for you. It's so easy, I'm not even going to show you an example of it, though. More than anything, it's just useful. It's a very useful formula. You don't ever have to use it. I'll show you in a second. There are a lot of ways to solve these problems. And this one just happens to be super, super helpful. Your pH plus your pOH should always equal 14. So if you have one and you want the other, it's really easy to go bounce back and forth between them. They both tally 14. Like I said, not even going to do a example with that. It's really quite simple. I think you guys are getting the hang of it already. And then I want to point out here that, again, there are a lot of ways to solve these problems. A lot of ways. All I ask is you guys to show your work, which you should be doing anyway. So I can figure out which way it was that you did figure it out. But if you take a look, depending on what you have, shows you the formula you'll need to find whatever else you have. So if you have your OH negative concentration and you're asked to find a pH, we've got a couple different options. There are several ways to go about this. Well, you could follow the arrow down, use this formula, solve for pOH. So it's negative log of whatever your OH negative concentration is. Once you have your pOH, just subtract it from 14 to get your pH. Pretty simple. But it doesn't have to be the way you go. There's a lot of different ways to solve for these. You could, if you have that OH negative, you could solve for your H plus. You know this formula. Once you have your H plus, you can then solve for your pH using this formula. So this is a really helpful tool. Just kind of helps you get your formulas lined up. But ultimately, guys, I'm just using it to show your homework tonight. When you're doing calculations, there's a lot of correct ways you can go about solving for the answer. A lot of different ways, really kind of up to you, whichever one you're most comfortable with or most familiar with or whatever. You have your H plus and you're looking for OH negative, you could do it directly in one step, you say here, or go the long way around and find a pH, use that to calculate pOH, and then go to OH negative. It's completely up to you how you like to solve your problems. Questions about any of that?